So the first thing we did today is we looked at possible inputs and outputs for these scenarios here. And so one thing we looked at is like if there was a negative number, you wouldn't have a side length with a negative number. In tennis camp, it wouldn't have a negative number. So we said like we could have a negative 10 there. And then we looked at the tennis camp. The camp runs only if at least 5 students signed up. So we could have 5 all the way to 16. And then numbers come out. We said they had to be multiples of 40 and at least 5. So we had said 200 had to be the minimum. And side lengths, we had, you could have 5 and 25. Temperatures, you could have 100 and 250. So temperatures was really big. So then we started talking about independent and dependent variables. We said independents are our inputs. Dependents are our outputs. So then we started to take a look at that first one. Here is the area equals sides squared. So we said inputs and outputs, and we made a table. So we said 2, if an output was 2 right here, that would go with 4 because you're squaring it. So there's the coordinate 2, 4. 5 would go with 25. There's the coordinate 5, 25. And 6 could go with 36. And here's the coordinate 6, 36. The next thing we talked about is it was non-zero because a side length can't be less than or equal to 0. So when it says all possible inputs are greater than or equal to 0, that's why, if it's a side length here. So the second one we looked at was the tennis camp situation where it was $40 for each player going. So was 20 a possible output? Now remembering output is our cost, we said no because the minimum cost was $40 per camper. And what about 100? And we said no because it has to be multiples of 40. So then we take a look at this. Here are 2 graphs that relate the number of students in the camp and revenue. Which graph could it represent? We said it had to be the second one because it needed to start at 5. And so this has all these numbers before 5. And it also had numbers like 5.5, 6.5, and you wouldn't have halves of students. So as the second graph, it's right on the dots. So the possible output values are multiples of 40 starting at 200. And that was because there's a minimum of 5 students. All right, so the next thing we did is we looked at this equation and we started to create tables. And we used our calculator and plugged in these x values. So we said 6 over negative 10 minus 2 is negative half. Then we plugged in 0, so 6 over 0 minus 2, negative 3. 6 over half minus 2, negative 4. We plugged in 2, 6 over 2 minus 2. Well, this gives us an error. And then we did 6 over 8 minus 2 was 1. Then it said to graph it. So we could go to Desmos here and say 6 divided by x minus 2. And if we look at the graph, there's an error at 2 because there's this big long line there. So when we look at it, there's an error at 2, and there's no graph there. Because when we put in 2, 6 over 2 minus 2, 6 over 0, and we can't divide by 0. So our inputs, all values, except 0. So our domain is our possible inputs, and our range is our possible